So we're on record now. We are doing non-proportional linear equations. A linear equation is a simple statement that the equation creates a line. So a linear equation creates a line, and we use that for a lot of purposes. If you had money in the bank and you withdrew $45 every month, if you withdrew $45 every month, go ahead, you can come in, Cordell. Just right here. Thank you. I'm recording, right? Be more. Thank you. I appreciate it. Shh. Go, y'all sit down. Mary. So, a linear equation creates a line. If you had $2,000 in the bank and every month you took out $40, your equation would drop down, right? But it didn't start at zero because you had $2,000. We talked about proportional relationships. They start at zero. And they rise or fall based on that starting at zero. Whereas the non-proportional starts somewhere else. And that's what makes it different. So they create the solution that are ordered pairs. When I say ordered pairs, what am I talking about? X and Y. An ordered pair, it has an X and a Y coordinate. So ordered pair means X and Y. And then we're graphed on a coordinate plane. A coordinate plane is just our X's. It's just our plane that we draw our line on. All right? Now, the only equation we're going to worry in here about this year is slope-intercept form. When you hit algebra, they're going to change it, but it really is all the same. It's just how it's presented. So slope-intercept form is y equals mx plus b. Now, here's the difference. In a proportional relationship, b is 0. So we seldom write something equals something plus 0. Why don't we write plus 0? Why don't we write plus 0? Because we know it really has no value in the equation. So it's very common. So in the case of m is the slope. What did we know as m before? What did we call it in the last relationships?
K.
We called it k, because k is the constant proportionality. It's the same as the slope. It is rise over run. The y-intercept is where the line crosses the y-axis. In a proportional relationship, it's at 0. So the y-intercept in a proportional relationship is 0, 0. In everything else, the x-coordinate is always 0, and the y-intercept is somewhere up and down the y-axis. So if I had a coordinate, and I had a y-intercept, right there is the y-intercept. It's where it crosses the y-axis. I'll go ahead and label that as the y-axis. The y-intercept is where it crosses the y-axis. At the y-intercept, the coordinate for x is always 0. And then b is something. And we'll figure that out. So far, kind of making sense a little bit? We're going to have some time to practice it. So, given all that I've said, what are the ways to differentiate between a proportional and a non-proportional relationship? If the relationship is linear, it is a line, then it'll either be proportional or non-proportional. That's what it'll be, if it's linear. When the graph of the linear relationship contains the origin, it's proportional. If the graph does not contain the origin, it does not go through the origin, it is non-proportional. That's as easy as it gets. Does that make sense? When I talk a line, I'm talking a straight line. There's no curving in it. Sit down. Sit down. Okay. So, an equation is only used for situations where x and y are continuously moving together. If we get in a car and we start the car and we go for a ride, our time and our distance are moving together, aren't they? As we drive forward, time is increasing, distance is increasing. That's a line. Does that make sense? If I have donuts, there's a box of donuts, and people take the donuts. Is it a continuous reduction?
Yes.
No, because you can't take half a donut. Well, you can, but you're that bad person. Donuts officially don't come in parts. When you go into the store and you say, I'll have a quarter of a donut, they won't serve you. They'll just mock you at that point.
No, you can get a donut.
Again, listen and pay attention. Stop coming up with exceptions. It's not a donut at that point. So donuts kind of go 1 donut, 2 donut, 3 donuts, 4 donuts, right? But there isn't 1.1 donuts, 1.2 donuts, 1.3 donuts. There's not a continuous line of donuts. If I'm filling a pool, I'm not sure what's going on, but I'd love for you guys to listen. Let's say I'm filling a pool with water, and I've got the hose, and I'm pouring the hose into the pool. Is the water rate rising continuously?
Yes.
No.
Yes.
Why?
Because the water's flowing.
It always goes by.
Yeah, the water's just flowing in and the rate is coming. Now, if I get a little bored and my hose is short and I call Landon over, I give him a bucket and he fills up 5 gallons at a time and walks to the pool and dumps it in. Is the water rising continuously?
No.
No, it's rising 5 gallons at a time, right?
Yes.
And Landon's getting tireder. That's the way that works. So, continuous means that there can be portions. If I'm counting people who attend a concert, is it continuous? Is it a proportional relationship, non-proportional relationship, or non-linear? Is it linear or non-linear?
Non-linear.
Why?
Because there can't be half a person.
That's right. You cannot have half a person.
But you said 5 people.
No!
Chase, be quiet.
People are always. So, buying apples, if you go to the store, you buy some apples. That's definitely not what it's going to look like on your graph. As you buy apples, it's going to look like 1 apple, 2 apple, 3 apple, 4 apple, 5 apple. But it's not a line. Whereas if we fill the tank, it's going to start from 0 and just constantly get full. Unless your pool already had water in it, which is possible. Now, the next part, we're going to hold system of equations till later. We're going to come back to system of equations. But it is no more than saying that there's multiple equations. You find the point where they meet. Any question on non-proportional linear equations? Good. I'll stop this one.